What are the 4 strokes? Intake, compression, power, and exhaust. Yes. There's a 5th event. What is that 5th event? Ignition. It happens after compression and before power. All right. Have you all practiced doing that spiral diagram? You must have, because you were handing them into Mr. Cliff. There will be questions that you're going to want to do that spiral diagram in the test. You may or may not have stressed this to you. After I wrote the test, I went and sat in the exam center and took the test like a student. And there were several questions that I could basically only answer with a quick sketch of that diagram. That's why we teach it to you and then make you hand it into us and answer some of those questions. And you will have some basic math, pencil and paper math, I hope, like how many degrees after ignition does the exhaust valve open? And it is way, way easier to answer those with a little spiral in front of you. Okay, why does the camshaft turn at 1/2 of the crankshaft speed? Because the valves only open 1 per cycle. Thank you, Braden. Perfect. The pistons go up and down twice per cycle, and the valves open up once per cycle. So we just do we just turn the crankshaft at 1/2 speed. How is the proper relationship established between the crankshaft and the camshaft? Yeah, and how do we make sure that they're paired properly? Mr. Cliff talk about this? Or did it come up? Let's just do something here. Insert new blank slides. New, and new. All right. And slideshow. Current slide. Let's eliminate. Oops, hang on. Display settings. Swap. Minimize. And now I can draw. Okay. If I've got a that's a circle, folks, just so you know. And then I've got that's also a circle, so don't laugh too much. What they will do is mark 2 teeth on 1 gear and mark 1 tooth on the gear that it mates to. And to set things up properly, you mesh them so that those teeth mesh together. And this way you know that the crankshaft, the piston, is near top dead center. There's my piston up at top dead center. And over here, my cam lobe is pointing this way. And this is exactly the way I wanted it to be for my push rod. Does that make sense? All right. So that's how they make sure that everything is correct. All right, escape. Discard my new notes. We don't need those. Okay, so that answers this question here. So how does the heat of combustion cause the piston to move downward in the cylinder? Should be pretty straightforward. Gas laws, we get pressure from heat. What's valve overlap? Both valves are open. Why are both valves open? What are the advantages? To include improve scavenging and cooling, yeah. Help cool the cylinder head, yes. So what happens is all the exhaust gas is rushing out, and the engineers and designers have figured out that we can cheat a little bit. The very first engines, I'm very sure, had the intake valve open at the top of the intake stroke and closed at the bottom of the intake stroke, and the exhaust valve open at the bottom of the power stroke and closed at the top of the exhaust stroke. But what they discovered was that if you cheat and extend these events a little bit, like the exhaust event is more than 180 degrees, right? It's more like 220 degrees, 230 degrees. And that's just more time to get exhaust out. That's volumetric efficiency. So we cheat, and they found that even more in the cheating, you can get a little bit of valve overlap and have both valves open. And because of the momentum, because the exhaust is already flowing out the exhaust valve, it won't make a 180-degree turn and flow at the intake. And it even creates a little low pressure zone that starts to draw a fresh fuel air charge in. So this pulls more cool fuel and air across the cylinder head and helps with cooling. And scavenging is that phrase means getting every last molecule of exhaust out of the cylinder. Okay, so what strokes does it happen on? End of which stroke and beginning of which stroke? End of exhaust stroke, beginning of intake stroke. Yep. Okay. TDC and BDC. Top dead center and bottom dead center. I don't think I covered this with you. Let's show you another kind of a neat trick that helped me understand why the exhaust valve is opened so soon. Display settings, swap, minimize. All right, minimize. See if I can draw this. I've got my crankshaft with my lobe here, and this is going to push to my piston. I've got, let's do it. Here's my piston at top dead center. Let's erase and do this the other way around. Let's move this. Here is, let's start with the piston at top dead center. Okay, now let's move to move that there. And let's move it down. A, B, C, D. Okay, so position A. On the power stroke, we're going to have our hot gases in here. I should change the color for those, shouldn't I? Let's make our hot gases a different color. Let's make our hot gases orange. I'm going to have our hot gases here. We've got our fire going on in there. What is the pressure in our cylinder right now? Very high, medium, low, extremely high, right? We're at the top of our compression stroke. We've got a fire going on in there. The burn is almost complete. I'm at the highest compression. What is my crank angle? Like, how much torque will I get in this position? A lot or not much? I got real high pressure. Will I get a lot of torque here in position A? No, why not? It has what we're going to call no leverage. So let's call this an Ineffective crank angle. Right, there's an ineffective crank angle. Okay, so position B, how about that? Am I going to start to get some torque in position B? Yeah, I'll actually get pretty good torque. I don't have a great crank angle, but I've got really, really good pressure. What about C? Do you think C will have more or less torque than B? Okay, but what about the fact that the pressure has dropped off? So position C will have roughly the same torque as position B, because we've got two things going on. We've got less pressure, but a better crank angle. So does it make sense? Can you see that position C will have almost the same torque as position B? So between here and here, we get good torque. Now, what about position D? Now, in position D, I'm starting to get much less torque because my crank angle is getting bad and my pressure is getting low. So the good spot, the sweet spot for making torque is right in this box. Here's where we're making good torque. Good, reasonably good crank angle and lots of pressure. When we get down to position D, we start to lose more and more torque. And this is why the engineers said, well, let's just open the exhaust valve. I've got a bunch of time here to get exhaust out. There's still some pressure in the cylinder, but we're better to use that pressure to get rid of the old exhaust than to try and make torque. So I don't know if that helps for you, but that explanation, this sort of understanding helped me understand why we open the exhaust valve so early, because we open it really early. That help you folks? I hope. All right, there we go. Discard. All right, so why does it open? It opens on the power stroke, and it opens so early, and you should be able to identify, this is something else you need to be able to know for tomorrow, which strokes the valves open on. So which stroke does the exhaust valve open on? The power stroke. What stroke does it close on? The intake stroke, right, all the way around on the intake stroke. That stuff is really easy to answer if you got a spiral diagram in front of you. All right, who invented the four-stroke cycle? Mr. Nicklaus Otto. And so we named after him, we misspelled it and called it the Otto cycle, and then we called it the automobile. And we misspelled his name to make the automobile. How are you folks doing? We're at 50 minutes. Do we want to break? Do we want to keep going? It was a fairly active little bit. All right. I'm thinking like we're still okay to go. You folks, compared to other classes, are a little more enthusiastic to just keep on going. So I'm happy to work with that. Okay, what controls the amount of fuel-air charge that enters the cylinders? How do we get more fuel and air in or less fuel and air into the cylinders? Throttle plate. Thank you. Travis, you're right. Mertcan, that's an even better answer. The degree of throttle plate opening. Okay, what are the advantages of valve overlap? I think we already heard that. Improved volumetric efficiency, improved scavenging, and improved cylinder head cooling. Okay. Why does the ignition event occur on the compression stroke? Okay, so the throttle is part of the carburetor. We'll learn about that in about a week and a half. Carburetor is Wow, you typed a lot there, Merkin. Nathan, I think you've got the simplest, and I really like that answer, to allow the time for the flame front. What we want, remember those four pictures? I don't want to redraw them. How much power do we get if we've got, or how much torque do we get with all the flame, at the top of and we're at top dead center? We get zero torque, right? Ideally, we want combustion to be done about 10 degrees, 12 degrees after top dead center. And that answer is directly out of that detonation article. I hope you have all found that detonation article. Really interesting read, very well done. Has anybody not been able to find the detonation article? All right, I'm getting blank, so I'm assuming you've all found it. The reason we ignite, you don't know where this article is? You have not. All right, well, let's just go here, pull this down so you can see it. Content. Detonation and pre-ignition article. This one. This is one of the best articles. No, actually, I shouldn't say one of the. This is the best article I've seen anywhere on detonation and pre-ignition, and really, really well written. I learned a lot reading it, so I liked it. Okay, so why do we do the ignition on the compression stroke? The idea is we want combustion to be complete. They talk about burning gases. Every little video you'll see talks about like burning hot gases. Well, when the piston is going down, we don't want them to be burning. We just want them to be hot. So we want the burn to be complete just after top dead center. Remember, this piston is flying by. We're turning at 2,000, 3,000, 5,000 RPM. How long is the piston, plus or minus 10 degrees of top dead center if we're turning at 5,000 RPM? Maybe a millisecond, right? We're talking thousandths of a second. And the flame takes some time to cross the top of the cylinder. So we need to light the fire a little bit early so that the flame has time to cross the cylinder head. Just, simple physics. Okay, so that's the answer to why does the ignition event occur on the compression stroke? What is the goal? The goal is to have combustion complete 10 degrees after top dead center, or 13 degrees, I think was the actual number. So we light it on the compression stroke to allow time for the combustion to happen. Why do we open the exhaust valve so early on the power stroke? Well, that was the drawing that I showed you. By the time you get to, 50 degrees before bottom dead center on the power stroke, you've got not much pressure left in the cylinder, and you've got a terrible crank angle, so you really just don't get any torque out of it. So they said, hey, let's just open the exhaust valve and start letting the bad stuff out so we can get all of it out and make room for the good stuff. Okay. Any questions so far? Is what I'm saying making sense? All good. Okay, the diagram, the H2. So what strokes does the intake valve open and close on? What's it open on? Opens on the exhaust stroke and closes on the compression stroke. Exactly. Mercan, you would miss out on that because the question will ask, what stroke does it open on? Are there any strokes with both valves open for part of the stroke? Which strokes have both valves open? The exhaust stroke has both valves open and the intake stroke. Yep. Are there any strokes with that don't have a valve open for any portion of them? The compression stroke doesn't have. Take a look at your spiral diagram. When does the intake valve close? This intake valve closes on the compression stroke. So the intake valve was open for the first like 40 degrees of the compression stroke, wasn't it? All right, so intake stroke, obviously not. Compression stroke, we've just decided, does not have both valves closed the whole time. Power stroke, are both valves closed on the power stroke the whole way? No. Which valve opens on the power stroke? The exhaust. And then, of course, the exhaust stroke has not only the exhaust valve open, but it actually has the intake valve open for part of it. So we don't have any strokes with the valves closed the whole time. All right, valve lead and lag. Sometimes students get confused on that terminology. Is there more lead and lag near top dead center or near bottom dead center? Bottom dead center. Yeah, way more at bottom dead center. It's like plus or minus 50 at bottom dead center and plus or minus 10 or 15 at top dead center. I think there's some math behind that I have never delved into. You can calculate how many degrees the exhaust valve is open for. You did all that. There are a couple of questions that ask you that. Sorry about that. And these questions should be fairly straightforward, right? Okay, moving down. How many degrees of crankshaft rotation is a stroke? (180). All right. 2 strokes. We don't have a whole lot to cover on 2 strokes. What causes the fuel air mixture to flow into the crankcase? Vacuum. I like Braden's answer. The question, Nathan, was into the crankcase, not into the cylinder. So the piston moving up in the crankcase. Did we cover the last 4 in the timing? Well, nobody's asked me any questions. You mean these 4? How many degrees is the exhaust valve open for? These are all referencing a particular diagram. So what are the answers? How many degrees is the exhaust valve open for, Intervere? Okay, what's your answer? The exhaust valve is open for 10 degrees. That most certainly is not right. Okay, how many degrees before top dead center does the exhaust valve open in the diagram? How many degrees before top dead center does the exhaust valve open? 20. I don't know. What's it from the, you got to look at the diagram. Shouldn't be a question. Look at the timing diagram and handout H2. Okay, so Sean, you said it's 25, right? Okay, 25 plus 180 for the whole stroke, right? Plus, so on the power stroke, we're saying that it opened 25 degrees before bottom dead center, which doesn't sound right to me. Normally they're more like 50, but that's what you guys say it was. And then 180 degrees. Yours says 60. Yeah, where's 25 coming from? 25 doesn't sound right. 60 plus 180 plus, oh yeah, okay. So 25 before bottom dead center, or 60 before bottom dead center, plus 180 plus 10 equals what? 190, 250. Right? Okay. How many degrees after the exhaust valve closes does the ignition event happen? All right, so the exhaust valve closed 180 minus 10, so 170. You follow me there? So the exhaust valve closed on the intake stroke. So 180 degrees for the intake stroke, 180 minus 10, and then plus how many degrees of the compression stroke? 180 minus, but don't forget it closed 25 equals, what's that come out to? You said the ignition was 25 degrees before top dead center, is that right? I don't have the diagram in front of me. 30. Because ignition is 30? Okay. If the ignition is 30, then that becomes my number. And we end up with 170 plus 150 comes to 320. If the exhaust valve is just starting to open, what stroke is the piston on? Power stroke. Yeah. Which valve has more lead, the intake or the exhaust? Okay, so the intake valve, how much lead does the intake valve? And we got, I forget your given name, or the name you go by. How much lead does the intake valve have? 15 degrees before top dead center. Okay. How much lead does the exhaust valve have? 60. So which is bigger, 60 or 15? So which has more lead, the exhaust or the intake? The exhaust does, correct. All right, kind of glossed over those. Okay, it has been an hour. Let's take 10 minutes. And you kind of know what's coming up. If you see any questions that are concerning to you, we'll be ready for those. So let's come back at 9:30.